Okay, so day 3 notes today, we're starting logs. A few things you got to be able to do from the notes. First thing we have to be able to do is convert between log and exponential form, which you've done before. Then we have to be able to evaluate logs. Last thing is we are going to graph logs. I will tell you the only thing that's going to be kind of new is we are going to graph logs a little bit differently than you have before. Theoretically, the way we're going to do it is hopefully easier than what you've done in the past. Okay, so first thing we have to do is we have to be able to convert between log and exponential form. Log and exponential form. So, I'm not going to read all of that to you because personally I think it's pretty confusing. But if you can write this down, here's what I do need you to know. Logs and exponentials are inverses. So if we take a log, the inverse of a log is an exponential function. The inverse of an exponential function is a log function. So then we see these two forms at the bottom. Exponential form, you take it's in exponential form, you can put it in the log form. Log form, you can put in exponential form. I think it's easiest to remember this if we just do some examples. Are you okay if we just jump right in? Okay, good. I had a student teach me this a while ago as a way to remember converting between log and exponential form. So I'm going to tell you the converting, but I'm also going to tell you I am embarrassed to use this acronym, so just give me a little bit of a break, okay? Here's what you're going to do. When you see a log form, so A, B, and C, we're in log form. We need to put it in exponential form. What you have to remember is the acronym is BAE. B stands for base, A stands for argument or answer, E stands for exponent. So our base is 3, our exponent is 5, and we set it equal to the answer. So 3 to the 5th equals 125. That is mathematically not correct, but the right form. Do you guys see that mathematically that's not correct?
It's supposed to be 5 to the 3rd.
It should be, but that's not the correct form, yeah. Okay, so that's the idea. Base exponent, set it equal to the answer. So again, not mathematically correct, but it's the right form. So if you do the next one, again, if you remember BAE, base, argument, exponent. So we get 6 to the 2nd, base to the exponent, is equal to our argument or our answer of x plus 4. So this is the exponential form, that is the log form. Now, we need to solve for x if we can, which in this case we can. So 6 squared will give us 36. So then ultimately we get x equals 32. Okay, so then in C, same general idea. I have base, argument, exponent. So my base is E, my exponent is 3, and I set it equal to x. Some of you I told this to the other day when you asked me, E is just a number. E is just a number, it's kind of like pi, it has its own symbol. Is this seeming familiar? Yeah? Okay, so then in D, we have base, argument, exponent. So we get b to the 5th is equal to the argument of b to the 5th. That's it. So again, that is exponential form. The other one is the log form.
What does the R stand for?
What does what stand for? That's a B. That's poorly written. But it stands for base. Okay. Anything before we go the other direction? Okay, so in E and F, we are in exponential form. We need to put it in log form. The general is log, again, base argument exponent. So in the equation that we have, the base is 2. So we have log of 2. A stands for argument. If you just remember answer, kind of the same idea. So our answer is 8. And then that's equal to the exponent. It's equal to 3. You all take 20 seconds and do F, please. It's in exponential form. Please put it in log form. Okay, hopefully we got log. The base is b. The argument or the answer is 1, and the exponent is 0. How do we do? Okay, so these two equations have exactly the same meaning. They're just written in different forms. So they are equivalent but different forms. Okay, you have to be able to convert in order to do everything else that happens with logs. So questions before we keep going? Okay. So that was the first thing we had to be able to do. Second idea is we have to be able to evaluate logs. So it says evaluate each expression. In example A, you see log base 10 of 1. Okay, so here's the idea with evaluating. A log is just a number. So log base 10 of 1 is some number. We have to figure out what that number is. So what you're going to do is every time that you're evaluating, set that equal to x, because x is what we're finding. We want to know what is that log equal to. I think we can agree that we are not particularly in love with logs, and so it's often helpful to switch forms. So that's what we're going to do. We have base argument exponent. So that gives me 10 to the x equals 1. So then the question is, what power do I raise 10 to get 1? 0. 0. 10 to the 0 would be 1. Okay, here's where I'm going to be really picky, though. It does not make sense to leave our answer as x equals 0 because the initial problem has no x. We wrote x there. So x equals 0 does not make sense. So I want your final answer to be reported as just plain old 0. I don't want x equals 0. And if you want to use the notation that I did, where you just circle the 0 or box the 0 and you ignore the x, that's fine. But do not box all of x equals 0 because that doesn't make sense. Now, on the right, you see a table of properties. That first one relates to this second property. Any time the argument is 1, like it was here, doesn't matter what the base is, the log will always be equal to 0. Now, either you can remember that, or you can do exactly what we did in part A and go through the process. Okay, without going through that process, anybody have an idea of what b would be equal to using those properties on the right? 5. Yeah, 5. Probably relates to this second property. X is the exponent. So we know that that log is going to be equal to 5. Now, that's helpful if you memorize the property, but if you don't, here's how you would go about that. You're going to set the log equal to x, and then you're going to switch forms. So we have base argument exponent. So we would get 3 to the x equals 3 to the 5th. Hence why x equals 5. So I will be honest, I don't memorize these properties because I don't think it's very helpful. I would just switch forms. Okay, you take, let's say 45 seconds, 30 seconds, start C. It's a tougher one, but just start it at least. Get your x in there, switch forms, and see if that takes you anywhere. So let's jump in. Like I said, this one's a little bit tougher, but I hope that we could at least switch forms correctly. Set equal to x, then we have base argument exponent. We get 7 to the x is equal to the cube root of 49. How do we feel so far? Okay, My guess would be what we are most uncomfortable with when solving here is that cube root. So let's just get rid of it. How do you get rid of a cube root? It is a 1/3 power. You cube it. You cube both sides. Okay, so what we're going to do is we are going to cube both sides. On the right side, it gets rid of that cube root and just leaves us with plain old 49.
Don't you have to raise it to the 1/3?
It is raised to the 1/3. So cube root of 49
Oh, yeah.
is 49 to the 1/3 power. Okay, so then over here, we have 7 to the x raised to the 3rd power. Anybody remember what happens to those two powers to combine them? They multiply. They multiply. So that's the power 3x. Okay, so then what's pretty convenient is 49 we can rewrite in terms of 7. Thank you. Okay, so 49 is 7 squared. Okay, so lastly, if the bases are the same like they are here, you can set the exponents equal. So our final answer is 2/3. Remember though, I do not want you to circle the x in your answer because we put the x in. So again, what that's telling us is this whole log has a value of just 2/3. Questions before we do the last two? In D, this one I will tell you it is going to be most helpful just to use a property. We're not going to switch forms. What's important for us to notice from this property over here, when this base and that base are the same, you just end up with the argument. So here's what that looks like. When the base and base are the same, you end up with the argument. So that whole expression is just equal to plain old 8. Okay, and then last one. We're going to do E, and then I'm going to give you all a quick break before we graph. This one looks a little bit different because it has this ln. This you do need to know. So hopefully we remember it maybe. ln is a log where the base is e. So the first thing I would do is I would rewrite that. ln means log base e. Then we have e to the 4th. That's what we're evaluating. Okay, so if we're evaluating that, we're going to set it equal to x. Then we're going to switch forms. So we have base argument exponent. So we get e to the x is equal to e to the 4th. Because the bases are the same, we end up with x equals 4. So again, what that means is the value of this log is just 4. Okay, I know it's been a long time since you all have done logs. Questions for me? Can you write down 2 things before we take a break? Off to the right, I want to quickly review special logs. So the first one we just saw. ln means that the base is e. So if you ever see ln like we did in e, that means that the base is e. Anybody remember the other special one? Either remember or can tell from the properties? We look at the property right above. If you ever see log and it doesn't have a base, that base is known to be 10. Okay, so if you ever just see plain old log, that means that the base is 10. So if you ever see a log without a base, the base is known to be 10. Okay, so all of this is going to move on to graphing. Thankfully, the way we're going to do graphing is similar to how we graphed exponential functions. So with exponential functions, we remembered our 2 points and we transformed them. It's going to be related to this. Next page, you are going to see some general graphs for logs. So there are 5 examples that you see. Okay. First thing to notice, is there an asymptote? Yes. Exponential, the asymptote was at y equals 0. Where's the asymptote now? X equals 0. Okay? Asymptote at x equals 0. What else do you all notice looking at this? Kind of 2 things I want us to be able to see.
They all intersect at 1, 0.
Okay, they all intersect at this point, 1, 0. There are some other points that are noted. Is there any special pattern about those? Audrey?
They're all at y equals 1.
They're all at y equals 1, so we have this point, this point, this point, this point, that one. All have a y value of 1. Is there anything special about their base? Not base, x. I just gave you the answer. So look at, it's equal to the base. So on this blue one, the base is 2, that's an x value of 2. The red one, the x value is 5, the base is 5. Okay, that summary box is not all that helpful. Here's what I want us to write down. So let's just cross that on out. If we think of an example, we're going to look at a specific example. Let's say we are looking at y equals 3 to the x. Okay, what was the first point we said that will definitively go through?
1, 0. 0, 1.
0, 1. 3 to the x will go through 0, 1. What's the other point? 1, 3. And we said it has an asymptote at y equals 0. Right, that's all reviewed. That's what we did in the warm-up earlier. Okay, so then when we started out logs at the very beginning, we said exponentials and logs are inverses. So if we compare this to y equals log base 3 of x, we know that they are inverses. Okay, what do we know about points when we have inverses? They flip. So that 0, 1 becomes 1, 0. Like we see on the graph. That's where the 1, 0 comes from. It's the inverse of 0, 1. Okay, so then that 1, 3 becomes 3, 1. Again, it's just flipping the points. So you don't even have to remember these points. All you have to do is remember these and be able to flip them. And then we've talked about with inverses, x and y's are flipped. So instead of there being an asymptote at y equals 0, it's at x equals 0. That's where these points on the log graph come from. In my opinion, I think it's tough to memorize 2 sets of points. So I personally memorize the 1 set and then just flip them. But it's up to you. We're going to do 2 examples and that's it. Does that sound good? I'm going to talk you through how I would do a problem like this. Okay, here's what I would do. I would say, I don't like logs, so I'm going to think instead about 3 to the x. We've already talked about always goes through the point 0, 1, and then 1 comma the base. Now we're not talking about an exponential though, we're talking about a log.
If it's like, shouldn't it be equal to oh. Never mind. Sorry.
Okay. We're not talking about an exponential though, we're talking about the inverse. And so this is going to become the point 1, 0. This is going to become the point 3, 1. So that's what we're going to graph. We have 1, 0. We have 3, 1. Which tells us our graph is going to go up this way, and it's going to come down. And then, of course, like we've done in all of the other problems, make sure you throw in an asymptote. This asymptote, again, is x equals 0, not y equals 0.
I remember my question.
Okay.
Shouldn't it be, since it's log 3 of x is equal to y, shouldn't it be y is equal to 3 of x, cause it's like the bay? And the
Okay.
y is your, or the x is your inverse.
Okay, this, so what I did not do is take this and put it into the other form. So these two are not the same.
Okay.
If I wanted to put this into a different form, I would get 3 to the y equals x, which is not what
Yeah.
I have here, right? This is the inverse of this equation.
Okay.
Okay, so here's what I did, Charlotte. If I took this equation and I wanted to switch forms, I would get 3 to the y equals x. Yeah, you agree with me?
Yeah.
Okay, I want the inverse of that though. So the inverse of that is switching x and y. That's where this equation comes from.
Oh, so when you're graphing logs, you always do like the inverse.
I do the inverse because this is the one we already learned how to do. So this was the very first one we learned how to do. If you can remember the first one, you really need to know anything about graphing logs. You just gotta remember to flip the points. Okay. Here's how I would approach something like b. Something like b, I would say, okay, we're log base 3. So the inverse of that is y equals 3 to the x. So that's the inverse. So y equals 3 to the x, we know is going to go through 0, 1, and 1, 3. This one's going to involve actually 2 steps. Because next thing I need to do is I need to consider the fact that it's actually a log. So now I need to say, okay, instead of 3 to the x, I'm graphing a log instead. So what that means is I'm flipping the x and y. Now, I'm not done because I still have to consider the -2 and the +1. That -2, what is that going to do? Move us right to. So this is going to move us right to. So this is going to become 3 comma something, and this will become 5 comma something. If I move right to. What is the +1 going to do? Up 1. So that 0 will become a 1, and that 1 will become a 2. So these will be our new points. We do need to move the asymptote. So we have a vertical asymptote at x equals 0. If we move right 2, it moves our asymptote right 2. So then we have the point 3, 1. And we have 5, 2, which doesn't fit on the graph, so just do the best you can. And that is our general shape. That is the way I approach these problems. I will tell you what your other option is. Before I do that though, is there any questions on these 2 problems that we just did? Okay, so I think it confuses some of us to start with these and then flip them. If that's you, that you don't like starting with these points and flipping them, that's fine. What you would need to do then is just memorize what we put in this box. If it's exponential, we have these 2 points. If it's log, we have these 2 points. So if you would prefer to just start with these 2 points for the log right off the bat, then do that. But you need to remember which points go with the log and which ones go with the exponential.